Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, whenever you natural log one thing to the power of another thing, you can actually take that 2 down here. So rewrite this as this. Now this now is a constant, so you can take it out here. So you determining whether or not this will converge, it really boils down to you determining if this will converge or if this will diverge. If this thing here converge, then when you times a constant, then that will mean that the whole thing here will converge. If this thing here diverge, when you times this, it's just going to get bigger and bigger, meaning this thing will also diverge. So this thing here really boils down to you trying to determine if this thing here will converge or if it will diverge. So looking at this thing, 1 over a natural log of n. Well, 1 over natural log of n, if you look at the if you look at the denominator, if you make the denominator bigger, then the overall thing here will be smaller than this thing here. So looking at the denominator, if you look at natural log like this will look like this. Y equals x will look like this. So you see n will always be bigger than natural log. N will always be bigger than the natural log. So if the denominator is always bigger than this denominator, if this denominator is always bigger than this denominator, then this overall thing will always be bigger or equal to this thing here. So here the denominator is bigger than this denominator here, always in the realm from 2 to infinity, 2 to infinity. Well, we know, we've seen this many times. If this thing here would diverge, so this thing here would diverge, this thing here being always equal to or bigger than this thing, then this will also have to diverge. It can't converge because it has to always be bigger or equal to. Well, this thing here diverge, therefore this thing being bigger or equal to this thing must also diverge. So going back to here, this thing we've established is going to diverge. So hang on. So this thing here we've established that it's going to diverge. Therefore, if you times this, the whole thing will still diverge. So therefore, going back to here, our original series will also diverge. Okay. So next one. So determine if this series will converge or if it will diverge from n equals 1 to n equals infinity. So press pause and have a go. Okay, so to do this, remember, in order for any series to converge, the limit of this thing has to head towards 0. So that's the first thing you should check. So check that the limit of this thing equals 0. Well, rewrite this as n squared, because if you multiply this out, this times this times this will then give you this. Well, remember, root a b is the same as root a times root b. So that's the same as you multiply. So this is like one bubble, this is here another bubble. So root a, root b, and then these two will cancel out, giving you this, and then the limit of this whole thing here heads towards infinity. Therefore, well, in order for any series to converge, the limit as n heads towards infinity must be 0. But here it's just going to get bigger and bigger and bigger. This thing here is going to diverge. Okay.